We'll wait for more 5 minutes, then we'll start. So, good afternoon, everyone. And we have covered till now the from week 1 to week 6 content, and hope you were able to solve the previous assignments well, because we have discussed each and everything, and we have also solved different tutorial question. So I think the assignment, the level was easy. Okay, so in this content, which is a week 7 content, we will see the first we will see the surface finish in machining, in which we will see different surface finishing process and their application, which has been taught in the lecture 1. And then we will see about the CNC machines and CNC programming, different CNC codes, and how to apply it in which has been taught in lecture 2. So okay, let's begin with surface finish in machining. Okay, so first of all, what is surface finish, and like why it is required in machining. So you can see that whenever you do a machining, right, whenever you do a machining, say it a turning or milling or drilling, any kind of machining, your aim is not only to manufacture a product, but your aim is also to manufacture a product with a good tolerance, right, a good tolerance and a good finish, because ultimately you are manufacturing a product for some application, right? You want to sell the product, or you want to use that product for a particular application in a particular industry or in a particular machine. So when you use that product in a particular application, you not only required a particular shape, but also you required a very good tolerance, a very precise object, and a very good surface finish, so that the application in which it is going to be used, it has no issue with that particular product. So therefore, surface finish in machining is a very important thing which has to be maintained. Okay, so once the machining has been done, then on the preliminary level, the grinding is required after machining to improve the accuracy, in order to remove the various irregularities and roughness and everything. So how does that grinding works? So grinding finishes further by eliminating some defects, like the lack of straightness, out of roundness, flatness, deviation, etc., etc. So therefore, immediately after the machining process, this grinding process is required to remove the unwanted irregularities from the surface. Okay, it also helps in the improving the accuracy. Fine. Now, the roughness which are produced by a machining process, it is mainly two types. Mainly two types of roughness are produced. One is the ideal roughness, and second is the natural roughness. So now let us understand what is ideal roughness and what is natural roughness. Okay, see, ideal roughness is that roughness, it's a very, from the name only you can see ideal, it is very very normal, very ideal kind of roughness. So it results from the geometry of a tool and feed, and it is a geometrical phenomenon with minimum possible magnitude of the unevenness result from a machining operation. So basically, ideal roughness is because of the tool, because if tool geometry is not proper, design point of view, feed or depth of cut is not, or any geometrical phenomenon is not good. So it involves a very minimum value of the roughness which can be produced. Now, the natural roughness. The natural roughness is that kind of roughness which are produced other than the tool geometry and feed. Like because of the the roughness generated because of the machining parameters or the environmental factors, like the built-up edge formation in the tool, the vibration which affects the finish. So this is all about the natural roughness. So we have seen what is ideal roughness and what is natural roughness. Let's now see this in a detailed manner. See, talking about the ideal roughness, so where the roughness is we get where the best possible result is available. The roughness or the unevenness obtained in case of ideal roughness is very low. So in this case, we are defining the value of the surface roughness in case of ideal roughness, because in natural roughness we have the effect due to vibration also, and other effects like built-up edges and other chatter and other effects also, which lead to the contribution in the roughness value. So we are ignoring that. We are ignoring that natural roughness parameters and just finding the value of the surface roughness considering the ideal roughness. Okay, so we have also seen this in previous class ki how to calculate the roughness value for a perfectly sharp tool, for a perfectly sharp tool uh, with uh, almost no edge radius or nose radius. The surface radius, the surface roughness is given by f upon 10 gamma s plus cot gamma e, where f is the feed rate. One second, someone has joined. Okay, so where f is the feed rate, 10 gamma s is the one second, gamma s is the side cutting edge angle, and gamma e is the end cutting edge angle, right? So this is for the calculating roughness when up with a perfectly sharp edge tool with having no nose radius. Fine. And when you calculate ideal roughness value for a tool with nose radius r, then h is given by f square by 8r, where f is the feed rate and r is the nose radius. This we have already discussed in the previous class, how to calculate this and how the roughness value with the cutting speed and other parameters. This is a very important formula you need to note. These two formula, one is this one, which is number 1, and one is this one, which is number 2. This two formulas are very important. You need to remember these formulas because these are used everywhere when you calculate surface roughness. Okay, now we'll see surface roughness in machining. So the various factors which affect the finishing, we have seen the natural roughness are, one is vibration. So what is vibration? Vibration is like how to avoid like vibration. We can avoid vibration when the cutting condition is properly chosen, like the vibration or the chatter. Chatter is the uneven vibration which is caused because of the different machining condition. It can be also because of the fixture, because of the tool, because of the workpiece unevenness. So by using the proper cutting condition, this vibration can be avoided. Okay. Second, build-up edges. We have seen what are build-up edges. Build-up edges are the edges in is a process or is a phenomena in which that because at a particular temperature and cutting condition, the material from the workpiece get welded to the tool. Okay, so therefore the tool geometry changes and the quality of the workpiece and the finish decreases. So it depends. It also depends upon the cutting condition. For example, built-up edges occurs when the speed is very low and the depth of cut is very high and the feed is very high and the rake angle is negative, right? And the coolant is not used. So these are the condition where the build-up edges occur. So we can use high speed, low depth of cut and low feed, positive rake angle, and we can use coolant to avoid build-up edges. Build-up edge. Okay. So these are the various ways in which this vibration and build-up edge can be avoided. So now let's see the variation of the surface roughness with the cutting speed. So you can see in the graph there in y-axis we have h maximum, which is surface roughness, and in x-axis, one second. Hello? Can you hear me?
Yes, sir.
Okay. So basically, like I was teaching about the surface roughness, है ना, and surface finish. So this we have seen in the last class also, what is the formula for the surface roughness, which is f upon 10 gamma h plus cot gamma e and h upon f square by 8r. This first one in the case of perfectly sharp edge and second one in the case of the nose radius. So this we have seen. So this only I was explaining about. So you have done your previous assignment 6.
Yes, sir.
So you were able to solve questions, right?
Yes, sir.
Okay, you have any doubt? You have any doubt?
No, sir.
Okay, fine. Okay, then so I was talking about
No,
the.
sir.
Okay, fine. So I was talking about the various factors which leads to surface roughness. One is the vibration, and one is the build-up edge formation. So I was talking about how build-up edge formation can be reduced. This I have talked in my first lecture. So what are the various factors to reduce build-up edge and all. So now mainly we are talking about the variation of surface roughness with cutting speed. So you can see in the graph we have in y-axis surface roughness, and in x-axis we have cutting speed. So you can see the ideal roughness is constant, like it's not changing with the cutting speed. See, you can see there is some value of the ideal roughness which is the minimum value. This is the for ideal some h, right? This is very minimum for in case of ideal roughness. Okay, and it is always constant because ideal roughness only depends upon the tool geometry and other things, so it does not vary much with the cutting speed because of its ideal nature. So we can say the ideal roughness, the value of ideal roughness, its variation is constant with the cutting speed, constant with respect to v, which is the cutting speed. Now when we see the total roughness, the total roughness will include the ideal roughness plus the natural roughness. So in ideal is very because of the basic phenomena, but in natural roughness we have this vibration phenomena come into picture, vibration and this build up edges. Because of this external phenomena and environmental phenomena also come into picture. Because of that there is a variation of the surface roughness and cutting speed. So we can see because of this the total roughness, because of the natural roughness part, decreases cutting speed. Because see, when cutting speed increases, then build up edge decreases. We have no. So build up edge is one of the phenomena which is acting in the natural roughness, right? So because of that the H natural decreases, and hence this total roughness decreases. Therefore we can say the total roughness decreases with the cutting speed. Okay, so we'll move to the next part.
Yes, sir.
Okay, now please pay attention from this part. Okay, so surface finish in machining. So basically we have different process for the surface finish after machining. When we do machining, so we need to do the surface finishing process. The surface finishing process, there are various types of surface finish process in machining. Okay, one is, these are the, like, there are different other processes also, but these are the very well known processes which are used after machining for surface finishing. Okay, first is lapping, then it is honing, then super finishing, and then polishing. In polishing we will see the buffing, and then we'll see electrical field assisted ultra finishing, and we'll see the magnetic field assisted ultra finishing. This is the overall content of the finishing process which we are going to see today. Okay, let's start with lapping. So first of all you should know what does lapping means. Okay, so you can see the setup, the lapping setup, in which you can see this blue color is the wheel rotation. Okay, this is some piston kind of thing, and in between this pressure plate and this wheel some grids are kept. Okay, this abrasives, you can see this abrasives are kept. This is our workpiece. Okay, this is, for example, see, you can see this black color, this is our workpiece, or this blue color, this is our workpiece. So workpiece is kept between the abrasives, the grid particles, the pressure plate with a piston, and a wheel rotation. Wheel is rotating, and above wheel, see, above wheel this abrasives are kept, and above abrasives the workpiece which is to be finished is kept, and from above, from the top side, a downward pressure is provided. Okay, so because of the wheel rotation and the downward pressure from the top side, this abrasive get inside this workpiece. Okay, this abrasives grade are the sharp material, right? They have a very, sharp edges. Because of that, it interact with the workpiece material and remove the irregularities or unevenness or roughness present in the workpiece. So this is the process called lapping, in which the surface finishing is done. This is the overall overview. And see, this is basically a theory, mostly a theory class, in which you have to remember what are the various pressures, and the working parameters, and different phenomena happening in lapping, so that in exam you will get directly question from the theory only, what are the working parameter of pressure in lapping, or what are the various working parameters used in lapping, and what are the materials used, what is the wheel rotation speed, and everything they can ask this. So you need to remember. Okay, sir has already taught, I'm just revising you, I'm giving a brief overview so that you can get revised. Okay, fine. So I'll read this. Okay, see, as I have already explained, the abrasive particle moves in between the workpiece and the lap. We have seen this abrasive particle, brown color, this is between the wheel rotation and workpiece. Yes? You have any doubt?
Yes, sir.
Any doubt?
No, sir.
Okay, fine. See, one important process is that lapping operation can be used for finishing external as well as internal surfaces. This is one of the very important points. See, this point is very important. Please note it. The lapping process can be used for finishing external as well as internal surface. See, when you have a, for example, cylinder, okay, you have a cylinder. So the cylinder, it's a hollow cylinder. It's a hollow cylinder, right? So in hollow cylinder, you have the outer dimension and the inner dimension. So both the outer finish and the inner finish, both is to be maintained, right? Therefore, in this case, lapping can be used because it is used for finishing external as well as internal surfaces. Okay. And now talking about the movement of the lap and grids, this grid movement is very randomly. It's not that they're moving in a particular direction only. This abrasive, this grid movement, their movement is very random. Okay. And talking about the material, you can say the lap is generally made from the grey cast iron and also with the this brass, copper, softs. Basically, it is made from the soft steels. Okay. And which abrasives are used? General abrasives like silicon carbide, chromium oxide, boron carbide. These are the general, and also sometimes diamonds. These are the general abrasives which are used in case of lapping. Okay. And see, when you are using this pressure, you are applying some air, right? You are applying some air to push it. So to apply the air, you need a carrier fluid. So this carrier fluid generally in lapping process are machine oil and grease. Okay. So basically, the functioning and the quality of finish is mostly governed in case of lapping by four parameters. One is the average normal pressure. See, you need to maintain everything for a process to be done, right? So here, one of the important aspect is the pressure to apply force. So this one is the average normal pressure. It has to be maintained. Second, the material size and the shape of the abrasive grit. Obviously, you need to see whether the size of the material is compatible so that it can be used in the process. And also the abrasive grit, the size of the abrasive grit also matters in case of lapping. Then the lapping speed, because the wheel is rotating, therefore the lapping speed of the wheel as well as of the motion of the abrasive, because abrasive is also moving, that is very important. And fourth is the concentration of abrasive, how much abrasive you are using, so that for a particular finishing process. So these four parameters are very important in case of lapping. Okay, can I move to next slide?
Yes, sir.
Okay, fine. So I'll show you a small video how lapping is done. Please see it.
Lapping. Let us see an example for lapping operation. Lapping is a surface finishing operation. It consists of abrasive table, workpiece, abrasive wheel, lapping tool. The lapping process uses the abrasive tool and dry polish wheel or abrasive particles and vibrates with workpiece between the lapping tool. Lapping gives high degree of surface finishing.
Okay, so this is the way lapping is done, right? So this is how lapping is done. So we'll see the major parameters that influence. See, when you are doing machining, and then you have two main criteria to fulfill. One is the MRR, which is a material removal rate, which is the output of any machining process, because you always want the MRR to be high in case of any machining process, right? And second is the surface roughness. The finish. So you want the surface roughness to be minimum or the finish to be very highest in case of any machining process, right? So to maintain this in lapping process, high MRR and low surface roughness, we have the various parameters. One is the unit pressure, which is P. One is the grain or the abrasive size. One is the abrasive concentration, which is Ca, and the lapping speed. We have seen that in the video also. One is the pressure by which the lapping tool pushes the abrasive on the workpiece. One is the size of the abrasive, because main cutting or main finishing is done by the grain, its concentration, and the lapping speed. Fine. Okay. We can see now the variation of MRR with the abrasive concentration, and also unit MRR with the unit pressure. So we can see from the first graph कि the abrasive concentration varies with the unit pressure. For example, you can see when we increase the pressure, okay, when we increase the pressure, 1 second, someone is joining. 1 second. Please try to join in time. It's already half an hour. You'll miss most of the lectures.
Okay, sir. Sorry, network issue.
Okay, no issues. Okay, fine. So I was talking about the lapping. Please watch the video in the YouTube for the previous part which I have covered. Okay, I have not covered much. Only 15-20 minutes I have covered. So please watch it.
Okay, sir.
Okay, fine. So we were talking about the graph between the material removal rate and the abrasive concentration. So you see, when you increase the abrasive concentration, you can see the MRR increases. So it is very good for us, but it increases, and after a certain point it start decreasing. After it reaches the maximum value, it start decreasing, right? Why it is happening? You can see here it is increasing, then it reaching the maximum. This is the maximum value, and then it decreasing. So this is the reason, because when you improve, for example, you have to do the machining, right? If you are increasing the abrasive concentration, then because of abrasive, more materials are cut, है ना? Because if you want to, for example, if you want to cut this ball, cut this rectangle, and you're using some abrasive particle, right? You want to cut this from this. So as you are increasing more number of balls or abrasive, it will cut more MRR will generate. But if you increase the concentration more, such that the density is very high, and it is not able to cut then because of the very high amount. So that after a particular critical value of abrasive, Ca critical value, Ca star, the value of MRR started decreasing. So we have to maintain Ca such that we get the MRR highest. It will increase the Ca from a particular amount, then MRR will decrease. So we need to see that. Okay. Also, we can see the variation of MRR and SR, surface roughness, with the unit pressure. So first we'll talk about MRR. You see MRR is R, okay, and MRR is Q. You can see when we increase the pressure, the Q increases, and after a particular point, which is called the P optimum, it again decreases. So what happen when when you increase the pressure? So at high pressure, more MRR movement, more abrasive movement will be there. So MRR increases. But what happen when you increase the pressure up to a certain range? There comes a P optimum, a particular pressure. After that, increasing the pressure does not affect anything. However, it decreases MRR. So therefore, MRR decreases. Right? Similarly, we can see the variation of surface roughness with surface roughness always increases with always increases with the this what to say pressure, because if you increase the pressure, then high MRR, because of the high amount of abrasives are there, so they will come in contact with come in contact, and because of that high amount of surface roughness will generate. So because of high increasing pressure, surface roughness increases. Okay, this is clear? Have any doubt?
Sir, surface roughness should be decreased now because you want to finish the surface. So,
One second. No, wait. Why you are saying surface roughness will decrease?
because we want to finish the surface, na? So as we see in that video, the bolt get more shinier, so the
Huh.
roughness will get decreased, na?
No,
Ah.
sir, your aim is to see what is your aim. Your aim is to decrease the roughness, right? Your aim is to decrease the surface roughness, okay? But
Yes, sir.
when you are increasing pressure, so what you are doing, you are making more abrasive to come in contact with the come in contact with the what, this your workpiece. Okay, you are pushing it very hard. See what is happening. I'll explain you it. What is, you have this workpiece, right? You have this workpiece and you have these abrasives, right?
Yes, sir.
And you have this plate in which you are applying pressure, right? So
Yes, sir.
when you apply a very high pressure, then this abrasives will hit the workpiece very hard, right? Because of that high contact or high energy contact of the abrasive with the workpiece, what happens? This abrasives, they create some impression on the workpiece. Because of that, surface roughness ultimately increases. So therefore, we have to find that pressure, that optimum pressure, so that because pressure has to be provided only, because pressure increases the MRR. So we can't keep the pressure low, but if we'll increase the pressure also, then surface roughness also increases. So that is contradictory. So therefore we need optimum pressure so that our MRR also increases and surface roughness also decreases. Have you got this?
Yes, sir.
Okay. Now we are coming to the second process. So lapping is over. Fine. Like any doubt in lapping?
No, sir.
Okay. See, now honing. So now second is the honing process. See, honing is generally do for the finishing of the just a lapping we did for the finishing of what? Internal, external both, na? In lapping, we can do the finishing of both surface, internal surface also and external surface also. But in honing, we do the finishing of internal surface only, mainly. Internal surface finishing. Okay, in lapping we did finishing of both, therefore, but in honing we do only the finishing of the internal surface, not the external surface. Okay, so what is there? See, this is the workpiece and this is the driver, which is moving in this direction, reciprocating this direction, and also rotating, and you can see the abrasive streaks which is present inside inside the driver, and when it is pushing up and down, the abrasive particle, it's removing the workpiece, moving the irregularity inside the workpiece. It is going inside the workpiece, right? There is some workpiece and here hole is created here and the abrasives are moving here. right? Abrasives are moving here. Because of that, the internal part of this internal part of the workpiece is becoming is having high surface finish. This is basically what honing is. Okay, so we have to see various points which are very important for honing. For example, see, the abrasive in the form of sticks are mounted on the mandrel. This is mandrel. This is mandrel, and which is allowed for reciprocating movement. And honing is specially and widely employed for finishing both the form and surface of the bores of IC engine, piston, etc. The range of job diameter that may be honed is 3 mm to is very important. Which dimension of workpiece you can be used for honing, which is that it is 3 mm to 1000 mm. Okay, and the grit size, honing speed and honing pressure varies. Like grit size are 80 to 600 mesh, and the bond honing speed is 15 to 60 meter per minute, and the holding pressure is 1 to 3 newton per meter mm square. So this you need to understand, because this can directly be asked in the exam, ki what like in the fill in the blanks or in the match the following something. Okay, and the finish achieved in case of honing process, this range of finish is achieved 0.0025 mm. It's very less, and 0.25 micron. So this amount of finishing can be achieved in case of honing. And the major limitation of honing is that its inability to improve straightness of a holes and work on tough non-ferrous metal due to the glazing and loading of the protective abrasives. So because of the various limitation, it is not used for the non-ferrous metals. Okay, so these are the various properties of honing which is used for the finishing process. So we'll see the next slide. See, today class is somewhat boring because it is mostly having the theory part. But when we'll move to CNC, you'll find it really interesting. Okay. So see what happens. The various important parameters which are used in honings are for that affects MRR and SR, which is the material removal rate and surface finish, are unit pressure, obviously, the time, the honing time, and the honing speed. These three are the most important parameters for the honing operation. Now we will see the graph of MRR SR with the pressure and with the VP. So we can see with the pressure both Q and R almost increases only, because we have seen last time also कि SR increases with the pressure and Q also increases up to a particular value, and if it will increase pressure more, it will start decreasing. So therefore we need to use the optimum value of pressure. This we have seen it. Now the cutting speed. So when we increase the cutting speed, so the MRR formula, when we see MRR formula, it is always area of cross section into speed, right? So always when we increase the V, the MRR generally always increases only. So therefore with increase in VP, the MRR increases. However, when we increase the V very high at high V, what happens? This, because of the temperature phenomena and other phenomena, there other factors also come into picture, and this Q decreases. But generally with V, MRR increases, and with R we can see with increasing in V, right? So when in very high speed, the abrasive will touch or cut the workpiece also at very high speed. Because of that, it will have a very harsh contact with the workpiece. Because of that, as speed increases, this surface finish decreases. Okay, fine. Can we go to next slide? Sorry.
Yes, sir.
Wait. Sorry, this is not correct actually. See what happens. I have talked it opposite. What happens if V increases, then the movement of the V is increasing. So the abrasive movement also increases. Because of that, we are not increasing pressure here. We are talking about the V. So therefore, the cutting action of abrasive on the workpiece increases at a very optimum pressure I am talking about. So because of that, with increase in speed, the surface roughness decreases. Fine?
Yes, sir.
Okay. So we have a small video of honing. Please watch it. Have you seen how honing is done?
Yes, sir.
Fine, na? Okay. Now we'll come to the third process, which is the super finishing process. So see, now super finishing, that honing and this lapping are the finishing process. But if you want to finish, like you want a more finish to your object, then use the super finishing process. And it is a process which is similar to the honing only, है ना? Both honing and super finishing uses bonded abrasive stick, moved same reciprocating motion and pressure, है ना? And how super finishing differs from honing? See, in case of super finishing, the strokes are shorter. Higher frequencies are used, up to 500 strokes per minute. Why higher frequencies? Because you want more finishing. Therefore, you want the cutting at a regular, very high frequency. Okay, lower pressure are applied. Okay, to because of the having high surface finish, workpiece speeds are lower, and the grid size are generally smaller. These are the properties of the super finishing which makes it different from the honing. Rest, it is similar to honing only. Okay, and you can see here कि this is the workpiece, this is the workpiece, this is the rotation of the wheel, this is the reciprocating motion, and this is the bond. These are the abrasive bonded. These are the bonded abrasives. Because of the movement of the workpiece and the reciprocating motion, abrasives get interact with the workpiece and the finishing occurs. So or cutting here the cutting fluid is used to cool the workpiece and wash the chips, and these are the various informative thing, and it is used for both finishing flat and external cylinder surfaces. Both it can be used. And you can see the result of the finishing is around 0.0 micron. See how small it can go. The small it can go, the best accuracy it has, because it is able to cut the small to small times of grid size also. Okay, fine. You will see a super finishing. Please see a video of the super finishing process. You I'll let you know.
Super finishing. Let us see an example for super finishing operation. Abrasive belt, rollers, belt guider and workpiece. In super finishing operation, a belt coated with abrasive materials runs over the surface of the workpiece to remove materials for producing smooth surfaces.
Okay, have you understood?
Yes, sir.
Okay, then we'll move to next part. Now we'll see what is polishing. Okay, so these are the finishing process which we are used to remove the the irregularities or the roughness. But now polishing is what you like you might have done some experiment in your BTech time, that like some you are like, for example, what to say, you want to polish, you want to polish some surface, so you are using that emery paper and scratch paper that you might have used in your homes also. That brown color scratch paper are coming, है ना? So
Yes, sir.
that papers are used they are used for to make a surface even, to remove the burrs, to remove the scratches, to smooth the rough surface. So this is mainly polishing it. So it is done to remove the burrs, the scratches, and to smooth the rough surfaces. Mainly it is performed with the help of the abrasive grains or which attached to a polishing wheel at very high speed, which is around 2300 meter per minute. And the wheel is made up of leather, canvas, belt, and even paper. Paper is called the emery paper. Abrasive grain are glued to the outside periphery of the wheels. Like, for example, this is the wheel, and here the abrasives are attached. These are the abrasives are attached here, right? Okay. And uh, it is used the same function of grinding. As the abrasive get worn out, new abrasives come into picture, and the grit size are used are, see, more is the grit size, then the finer polishing it is there. It is, for example, for less grit size, for rough polishing. Rough polishing means when you have the high big irregularities, and when you have for like medium irregularities, then finish polishing. And when you have like very high, you want to do very smooth polishing, very less you want to cut, then you have to use higher grit size. More is the grit size, very fine is the polishing. Okay, so it is used for in various processes, like in the aesthetic purpose, in rusting, corrosion, reducing micro dents, removal of opacic layer. These are the various applications in which it is used. This is very informative things, you need to see that. But you need to at least remember the parameters value and this grid size and everything. Now, various polishing methods have been developed so far. So they are like polishing by abrasive belts, coated abrasive wheel, tumbling, soft and flexible wheel, electro polishing, magnetic field assisted polishing, and magnetic float polishing. So out of this, we will see some of the process. So one of the polishing process is buffing. What is buffing? Buffing is like what to say? It is similar to polishing process, but its function is different. है ना? So it is used to provide attractive surfaces with high luster. When you want, generally it is used to polish the metals. When you want a very good, good lustrous, for example, if you have seen like aluminium foils and aluminium material, they have a very lustrous look, surface finish. So that level of polishing requires buffing. Okay, so buffing mainly have a mainly have a grinding type of wheel, and we have some feather attached, and this feather used to shine the surface and remove the irregularities. Okay, it is generally it is used for very fine finishing, and
It is also used in car polishing also.
what
The same kind of buffing like setup is also used in car polishing and
right, very right. This buffing is used in the car quality, yes. Okay, so this buffing is this buffing is used in the rotation of the wheel, so therefore the speed is maintained to be this much. So this all you need to remember. This is very theoretical thing. One is the magnetic float polishing. So what happens in magnetic float polishing, that you use a magnet. Okay, you, for example, see, you have used a magnet north south, and the abrasive grains are there in the fluid, and then a shaft is there and a workpiece is there. So because of the north south attraction and the abrasive, there is the movement of the abrasive, and because of that the finishing is done. Okay, so generally it is used to do the polishing of the ceramic balls. It is very important. Also, a magnetic fluid which is composed of water and kerosene, which is carrying fine ferromagnetic particles, are carrying the abrasive grains, and because of this process only, the ceramics balls get this proper polishing because of this method. Okay, now other method is the magnetic field assisted polishing. This is the same use it for the ceramic particle also. Here what happened, two big magnets are used. One is the south pole, one is the north pole. Because of that, a magnetic field is created. Okay, they attract, and in this between abrasives are used, and because of that, the attraction of this abrasives, the abrasives here are attracted to abrasive here, so they start moving, right? They start moving, and in between workpiece is there. So while moving, they interact with the workpiece, and they reduces the finishes surface roughness and leads to better polishing. Okay, one is electro polishing. So electro polishing is the reverse of electroplating. The workpiece in electroplating, the workpiece act as cathode. Okay, but here the workpiece act as anode here, and the material is removed from the workpiece by electrochemical dissolution. You have seen the ECM, electrochemical dissolution, in which you have a workpiece, right? and it is kept inside a solution, and one is plus, one is negative. It is connected to some voltage, and because when we on the current or voltage, then because of this solution, for example workpiece is called anode है ना, so because of that this from here the material start removing, and hence it become more and more finishes. This is a very typical ECM process used for electropolicing. Okay, these are the very theory part which is used for the finishing purposes. Okay, so have you understood this?
Yes, sir.
Now this was the finishing process. Now you have any doubt in any finishing process? Can you move forward?
Yes, sir. No doubt.
Okay. So now we will see CNC machine and CNC programming. So can you tell me the full form of NC and CNC, anyone?
Sir, computer numerical control.
Okay, fine. So NC is the numerical control and CNC is a computer numerical control. So what happened? See, what happened earlier, we were using the conventional machining process like milling, drilling, turning, and various other grinding, very conventional, in which every process, every step was very manual. If you want to finish it, you need to manually, you need to measure it. For example, if you want to do a particular finishing process, then manually you are measuring each and every dimension, each and everything. That was a very time consuming and very hard work process. But later on this NC and CNC developed, in which what happened, the process is well defined or controlled by a computer, just like our desktop or laptop, it has a CPU, right? Our desktop has a CPU, which is the it control everything, like it has we can automate things like that. Using the CNC we can automate our process, like we give it a program. For example, what happened, what is the process flow? See, we give the input, input can be in the form of codes to this CPU. It process the input, it then do the conversions, and then it is output. Like, okay, for example, you have given input, for example you are doing drilling, so you have given the input to the machine to move the drill from here to here. Then you need to give the code, the G code, M code, which you will see later, and then it will read it and then move it. Then the machine will move from here to here, from 1 to 2. This is a very important CNC machine. Because of that, our machining or our work has become very easier. Okay, this is all about the CNC and NC machine. Now we'll see what are the various advantages and disadvantages of the CNC and NC machines. Fine. So various advantages are like, where it's very higher flexibility. You can use the machine anywhere, or you can give any process it to you do this. Second, because of this, the productivity is increased and quality is also increased, because doing it automatically is way more good than doing it manually, na? Because manual will always reduce the quality. Third, it reduces the scrap and the rework, because the finish is very good, so you don't have to do the rework again, and also less wastage is reduced. Inspection time is reduced, because the good work is done and the good finish is there, so inspection time is reduced. And then non-productive time is reduced. Manpower is reduced, because all the work is done by the machine. Cycle time is reduced, because because it does very fast for any machining. It gives higher accuracy. It reduces the lead time. Operational safety is reduced, because no operator is there, so there is less chance of any accidents. And machining of advanced, we can do machine, because when you are manually doing or by hand you are doing, so you cannot machine every material, right? You cannot machine every hard material, because you are doing it yourself. But with this you can machine advanced materials also, very harder materials also. And also by hand you cannot make complicated shape. You can make simple shapes, but making complicated shape is very difficult. Therefore in this also you can make very complicated shapes and contours. So what are the disadvantages of CNC? First of all, high cost. Machining is very high cost. Second, because ultimately it is automated, but someone has to operate it. Someone has to know every function of what command, what code has to be given. So how training cost and also maintaining cost is very high. These are some of the advantages and disadvantages which are used in the CNCs. Okay, is it fine?
Yes, sir.
Okay. Now we will see type of positioning system in CNC programming. See, so basically there are two types of positioning system in CNC programming. One is the incremental system and one is the absolute system. Can you tell me what is incremental and what is absolute system? Anyone? Anyone knows? Hello?
No, sir.
Okay, see what happened. This is your coordinate system, right? This is your coordinate system, y and x. Okay, in case of absolute system your origin is fixed. In case of absolute system your origin is fixed. Okay, for example this is our origin. Origin can be anything. I am considering this as origin. Okay, now you have to move from this point whose coordinates are this 2, 3. Okay, this A point. Then from A you need to move to B point whose coordinate are 5 and 6. 5, 6. It is 2, 3 and it is 5, 6. Okay, so this coordinate when you are defining with respect to this origin only, which is the starting or initial origin. You have not changed your origin, right?
Yes, sir.
Okay, but in case of incremental system, now for example let's say incremental. In case of incremental system, your origin changes. Okay, I am taking the same example. It is 0, 0. You are first in the point A, which is 2, and this is 3. Similarly, you are in the point B, which is this complete distance is 5 and this complete distance is 6. But the coordinate of A is 2, 3. Can anyone tell me what is the coordinate of B?
3, 3.
Right. Why 3, 3? Because when you are moving from A to B, now for B, this is not the origin, this is the origin. Right. So with respect to A, we will see what is the position of B. Actual position of B is 5, 6 only. But in the incremental system, we will forget this as the origin, and now our new origin is A. This is our new origin. Okay. So 3, 3. So this distance is 3 and this distance is 3. So the new coordinate of B is 3, 3. Have you got this?
Yes, sir.
Okay, fine. Wait, someone is, I think, joining. 1 second. No, fine. Have you understood now? Can I move forward? Okay.
Yes, sir.
So now, when you are moving from one point to another, so you can move point to point, है ना? And or also you can move in a path. Like when you are moving in a straight line motion, it is called point to point motion, and when you are moving in a circular path, it is called, or any curve, it is called continuous path. Okay, continuous and circular. Okay, fine. 1 second. Okay, point to point means moving in a linear straight line, and continuous path moving on a curve or on a and some circle. Okay. Now we will see what is interpolation. See, interpolation is nothing when you are moving from one point, A point, start point, and the end point. The path it cover, it is called interpolation. Okay, when you move on a straight line, it is called linear interpolation, and when you move on a radius, it is called circular interpolation. Fine, it is clear. When you move on a straight line, it is linear interpolation. When you move on a circular path, it's called circular interpolation. But you should know, whenever you move between 2 points, for example, you are moving from 1 to 2. Okay, then for complete path, your direction should be same. It's not like you are moving from here to here and you're changing direction. It is not like that. Its direction should be same. Okay, this is so the one is the starting point and 2 is the finish point. Always you go from start to finish. Okay, from 1 to 2, not from finish to start. You start from here, so your final is 2, which is the finish point. Okay, this is all about the interpolation. Now we'll see how to program. When you're moving from one point to another, you have to write a code, right? Then that code is where that CNC code has a particular format or a particular sequence. So that sequence is N G X Y Z F M S T. Okay, N is just the block number. It is not required as much. G is the G code, which is very important. We will see next. G code. Then is the position. These are the final position where the block has been reached. These are the final position. For example, you are going from 1 to 2. Then this position you have to this position you have to write, final position. Then F is the feed, at what feed it is moving. M is the M code. M code we will see later. What are M codes? S is the speed, the spindle speed it is moving, and T is the tool function. So this you need to remember. This sequence has to be followed. Only this sequence has to be followed. Okay?
Yes, sir.
Okay. Now, do you know anyone know about what is G code? Hello? Anyone any idea about the G codes?
No, sir.
Okay. See, when you want to do a machining, for example, this is the workpiece. Okay. You want to cut this portion, right? Cut this portion only. So you need to, first what you will do, you will put your tool here, na? Wait, 1 second. What you will do? You will put your tool here, then you will start moving here, like this, and you will cut, and finally you will get this material. Fine? Finally you will get this material.
Yes, sir.
But what happened? When you will do this, so computer don't know na ki how to move, how to cut this. So this you have to give it. You have to give the code. So you have to give the code. That code will include what is the G code, what are the various X, Y, Z value, what are the feed, what is the spindle speed, what are the various tool, everything. So this G code are the preparatory functions, which are also known as geometrical codes. Geometrical codes, right? It is related to the geometry or the coordinate of the system. For example, if you want to move from here to here, right? First thing you have to define in which system it is using, absolute system or incremental system. Okay? You have to define this. Then you have to define, for example, it is here x is equal to 0 and y is equal to 0, and here it is x is equal to 2 and y is equal to 5. Then this dimension you have to give. And how it is moving line to line ekdam linear, or it is moving very transverse like this. Not you have to go from this to this. So you can go either line to line or directly like in haphazard manner like this, for ekdam very fast manner like this. Okay, so how this this every code is given by G code. Fine, understood?
Yes, sir.
Now there are various G codes. So some of the very important G code we will see. See, these are some of the very important G code. Very important. Please, if you don't have this value, please note it or take a picture. Okay, see. So I'll explain each G code one by one. First is G00. G00 means when you're going from one point to 2 point. You are not following a linear path or point to point path. You're just moving fast like this. You know, you're not following a linear pattern, but you just have to move to reach from 1 to 2 very fastly. But see, this G00 when you can't use this G00 while machining, because when you are machining, for example you are machining this product, you need to move in a line, right? So there you can't use G00. But when you are machining, for example, you have tool here, but after machining you want to take tool outside, then you can take tool outside using G00, because you have to just pull tool outside, right? Therefore no linear pattern is required. For example, this is the tool and this is you have to cut. So while cutting you need to follow this part, na? Then you don't have to use G0. But after cutting you want tool to come upside. Then while coming outside there is no obstruction in between. So directly you can use G00 for fast movement. Okay. Now it is G01. So when you want to move in a line, here you will use G01. Just same. If you are moving in a line, so generally while machining we are using G01. So that to follow a linear pattern or a point to point contact. Okay. Now this is for a linear pattern, but when you are moving in a circular pattern or arc or in a clockwise direction, you are using G02, and when you are moving a circular pattern in anti-clockwise direction, you are using G03. Okay. Now while machining, for example you have to machine this much from 1 to 2. You want to machine till here, then you want some time the tool to rest and then start. Then this is called G04. G04 is the ideal time or the rest time which is given to stop the machine. Okay. Now G20. You are moving now. You are moving from here to here to here. For example, you are moving here from here 1 to here. Then this. You are moving each point, right? Then how you are moving? If your increment is in inches, you have to give G20. If your increment is in mm, you have to give G21. For example, you are going from 1 to 2 here. So how much? If it is in inches, you have to give G20, and if it is in mm, you have to give G21. Okay, one is G28. Now, for example, if you want to start any machine, you always want everything to be in its home position, right? For example, see, this is the tool, this is the workpiece, and this is the bed in which the workpiece is kept. So before any machining start, you always want this tool to be its home position, this bed to be in home position. Okay, so before starting any machine and after the machining is finished, you give this G28 so that the tool and everything goes to its home position. Okay. Now G40, G41, G42, these are the cutter composition. For example, if you want to, this is the machine, this is the tool, and if you want to cut this, so tool has also some radius, na? Tool has also some radius. So while cutting, it is possible that the tool radius also come in contact or can included in that cut part. So that radius effect we need to discard. Because of that, we are using the cutter composition. When you want to do it on the left, you see left. When you want to use it in the right, you use right. And when you don't want to cancel it, just use cancel. Okay. And we have seen already absolute and increment. For absolute system, use G90. For incremental, use G91. Okay, and also when you are moving your feed, you have to give some feed, some velocity to your tool to move forward. So you are, if you are giving per minute, it is G98. It is coming per revolution, then it is G99. These are the various code you need to understand. Is it okay?
Yes, sir.
So you have to remember this. This is very important. At least this. See, at least you have to remember this. G00, G01, G02, G03, G28, okay, G90, G91. This you have to remember at least. Okay. Now this is very important. Please pay attention. Very important. How to write the code. Okay. My screen is visible now.
Yes, sir.
Okay. See, when you are showing the linear interpolation, so in linear interpolation, what was the code? G01, right? G01 for linear interpolation. So, up, for example, you have to see, this is A point, this is B point. A is the start position, B is the end position. Okay. Now you have to move from this A to this B. Then how you will write the code? See, first of all, you will write G01. G01 is what? You are moving linear interpolation. Right? Okay. Before G01, you need to mention which axis you are using. If I am using the absolute, then what is you will write G90. Fine? If I am using incremental, then what I will use G91.
Yes.
I am using here absolute. I'm using here absolute, for example. So I'll give G91 for absolute, and I have to move linear, then I'll use G1. Okay. Now I'm going from x00 to x to position 5, 12. Then I have to write the final position. So final position is x5 and y12. Fine. Okay. And then I have to write the feed. Which feed, for example, if it is a feed 200, then I need to write this feed has, then I have to write the speed. Speed is, for example, 5000. So this is the complete process. So basically you need to remember this three mainly. What interpolation you are using and what is the distance you are using. Okay. Always use the final distance. Okay.
Yes, sir.
Okay, this linear is very easy. Now, when when you're going for the circular, see, you're going from, I'll draw it once very clearly. Okay, this is x, this is y, this is coming from here to here. This is 1 point, this is 2 point. This is the start position 1 and 2 is the second position, right? These coordinates are 0, 7. One coordinate are 5, 12. Okay, fine. Now you need to, this is a circular interpolation. Now you need to write the code. Okay, so when you are writing the code for a circle, first of all thing is that you need to define the center. Okay, so you have to define the center. Generally center is given. So if you'll see if you'll make the circle, this is the arc, this is the center, right? Understood this?
Yes, sir.
So center coordinates are 5, 7, right? This is 5 and this is 7. Okay? So for writing circular interpolation, there are two methods. One method is just using the radius. Here what is the radius? Radius is this This is 5. This is the radius. Okay? So just write Z0. It is going in which direction? See, counterclockwise direction. This is clock. This is counterclock. Then for counterclock you will use G03. For clock you will use G02. Fine?
Yes, sir.
And what is the final position? This is the final position. So final position x is 0, y is 7. Right? And what is the radius? Radius is 5. Then R 5. Done. Have you got this?
Yes, sir.
Second is the method of by using the center method. Center. In this you need to define the center coordinate. The center coordinates are I comma j. See how to find I comma j. So you will start with g03 only. X is equal to 0, y is equal to 7 you will do. Now what is I? I is the distance I is the x distance between the center and the initial point. So what is the x distance between the center and initial point? Can anyone tell me? Hello?
Sir, center and initial point.
Huh?
So center is 5, 7, 5, 12. So 5.
0 na. Center is also having x5. 1 is also 5. The x distance is 0 only na.
Okay, okay. Yes, sir.
There is no this change in x. So x distance is 0. So we will write I0. Right? And what is the y distance from the 1 and the center point? This is 12. This is 7. This is how much? 5 na. But you are going from up to down. You are reducing it na. So j will be minus 5. Got it?
Yes, sir.
So this is how you write for ij. See, G03 is for counterclockwise, x0 y7 is the final position, and if you are using radius, just write the radius. And when you are using, see, first you will do for any circular interpolation, first locate the center. After locating center, if you want to code by radius method, you'll see which direction is there. If it's clockwise direction, use G02. If it's anti-clockwise direction, use G03. Then you write the final position. Always write the final position. Final position is what? X0, Y7. Okay? And write the radius. What is the radius? 5, R5. Now second, coming to center method. Same right till here. Then you to locate the center. I and J. So I is what? The offset between the center position and the first position. So first position and center positions lie on the same line. So there is no x offset. Then I0. And y offset is there because first lies on 12 and it lies on 7. So it is 5. But it is coming down to j minus 5. Okay?
Yes, sir.
Any doubt?
No, sir.
If you have any doubt, please ask it. This is somewhat complicated. I'll explain once if any doubt is there. Okay?
Sir, the feed rate, how to specify the feed rate? Means what is the units for that?
Right. This is before writing this na. You need to write, for example, if you're using feed rate in inches per minute, then before this you write here only G20. G20 will put the feed rate in inches per minute. If you're using feed rate in millimeter per minute, then use G21. Fine?
Yes, sir.
Okay. Now coming to M code. G code is clear?
Yes, sir.
So like G code was a geometrical code, M code is a machine code. G code include every parameter of coordinate system. Na coordinate system, x, y, z coordinates. This include every coding of the machine related things. For example, if you want to move the spindle clockwise, then M03. If you want to rotate the spindle anti-clockwise, M04. If you want to stop the spindle, M05. If you want to change the tool, then M06. If you want to on the coolant, M08. Off the coolant, M09. If you want to program an M30. So this you need to remember. This is all related to machine thing. For example, first what you are doing, you are applying first G code, right? For example, G90, and then you are using linear interpolation G01, then you are using X5, Y10, then you are using some feed, for example feed 100, then you are using some S, है ना? S something, S 5000, right? But before this you need to give this S direction, right? So you need to give upside M03 or M04. to make this F move clockwise or anti-clockwise. Or example, before that you want to change the tool, then you have to write M06. If you want to on the coolant before machining, you have to write M08. So this machine parameter you have to give before the writing the G code. Okay? Fine?
Yes, sir.
These are the machine parameter, because before machining you need to set up your, before actual doing the cutting, you need to set up your machining na, ki what is the spindle direction, what is which tool to be used, whether coolant to be used or not. These are the various parameter you need to see. Okay, this is all about the M code. And there is cutting speed is given by S, which we have already discussed. This is nothing new. So this completes the today's session. So you have any doubt, please ask me. I'll clear it, then we'll move to the question answer round. Any doubt in G code, M code, any finishing, anything, please ask me. Then we'll move to the question answer round.
Sir, please explain that center.
Okay, fine.
Not the radius, but IJ1.
Okay, fine. See, please listen it. This we have a system, right? This is X, this is Y. Okay, see, I have a curve. This curve, I have to go from 1 to 2. Okay, this is there. One coordinate I know, it is 1, 2. The coordinate of 1 is 1, 2. And coordinate of 2 also I know, it is 5 and it is 6. So coordinate of 2 is also 5, 6. Right? This is clear? This is given. Fine, na?
Yeah. Yes.
Okay. So first of all, when you are doing a circular interpolation, you need to see the direction. In which direction it is moving from 1 to 2?
Clockwise.
Clockwise. What is the code for clockwise?
G02.
Fine. It is clear? Now, what is the final position of the second point?
5, 6.
So X is 5 and Y is 6. Fine? Now
Yes.
I need to, now I to locate the center. So where is the center of this arc? This will be the center. For this
Okay.
arc, this will be the center.
5 and 2.
5 and this is
2.
not 2. 5 and 2. Okay, fine. Right? This is the center. Now I need to find what is I and what is J. Right? I is what? The distance of the center from the initial position. So initial position is this and C is this. So what is the distance from 1 to C? X distance. This is the X
Yes.
distance, right?
So this is 4.
4. So I is 4. Fine. And J. J is the distance, Y distance from the initial position to the center. It is having the 0. 0, na? One
Y distance from the center.
from the center to the initial position. So see, set 1 is also having here and C is also here. So there is no difference in Y, na?
Yes.
It is 0. So you will write I 4 and J 0. Understood?
Yes.
Clear, na?
Yes.
Okay. Okay, fine then. We can move now forward over answer question. This is very critical thing. Any other doubt? Any other doubt? Anyone?
No, sir.
No.
Okay. Then okay, let's start our this answer question round.
One thing, is NC and CNC same thing?
No. See. 1 second. NC is numerical control. CNC is computer numerical control. Okay. Numerical control is kind of, you can say, a semi-automated process. Right? because in NC you need to give each and every, see, it is the machine is moving it by itself, but every step you need to tell, okay, move, it will move. Okay, for example, if you want to go from 1 to 2 and 2 to 3, then you have to tell grow from 1 to 2, and you each and every step you need to you need to feed. In CNC also you have to give each and every step, but in CNC it is automated. If you once start, it will move from 1 to 2 and 3. But in NC there is a computer, which there is some CPU, there is some brain, right, which enables it to give a continuous motion. But in NC you have to start one say 2, then it will stop, then you have to again you have to give the command, then it will go to 2 to 3. It is kind of semi automated process,
Okay.
right? And this CNC is the automated process. Fine.
Okay.
1 second. Means in CNC basically you can say you have a computer to control the system, and in NC you need to do the manual intervention. Okay, fine. Fine, na? Hello? Hello? Can you hear
Yes.
me? Okay.
Yes, sir.
So in CNC you have a computer control system, but in NC you need to do the this. See, NC was used long before. It was having some punch taped something that I am not going to discuss. So you have to do everything manually. For example, you have to go from 1 to 2. You have to do it manually. Then 2 to 3 manually. 3 to 4 manually. No, it's not semi-automated. Also, it's all manual only. Don't take it as semi-automated. Take it as manual only. Okay. But in CNC, it is automatic. 1, 2, 3 to 4 automatic. Fine.
Yes, sir.
Okay. Okay, then we'll start our answer question. This is our first question. Which of the following statement are incorrect? Okay, please read it and tell me the answer. Incorrect, not correct. I also want the explanation why you are saying this. Very easy. Just think of the formula. So have you got it? Hello? Hello?
No, sir.
No. So should I solve it? See, we'll see each and every point. Na? We'll say A. We'll see first A. It is saying when a tool without nose radius. So without nose radius, the roughness value is how much? F upon 10 gamma S plus chord gamma E, right? The ideal roughness is directly proportional to feed. So ideal is directly proportional to feed. It is right? है ना? It is right only, na? Hello.
Yes, sir.
It is right, so it means it is not incorrect, so we can't choose A. We need to find which are incorrect. It is right, it is not incorrect, so we don't have the answer A. Now we go to B. When a tool is with nose radius with rods radius, what is the value of h? It is f square by 8r. It is saying the ideal roughness is directly proportional to the square of the feet. So yes, it is right, h is directly proportional to f square. It is also correct. Therefore B is also not our answer. Now move to C. When a tool without nose radius is employed, the ideal roughness is directly proportional to the end cutting edge. So see here, it is not directly proportional to, it is inversely proportional to end cutting edge. So this is wrong. So this is our answer. Also see D. When a tool without nose radius is inversely proportional to side cutting edge angle. Hello.
Yes, sir.
See. This is also right. It is inversely proportional. It is right. No, it is inversely proportional. This is right. Therefore, the answer is C. Understood?
Yes, sir.
Okay. So we need to find the incorrect one. The incorrect one is C. Rest A, B, C, D, A, B, D are correct. Okay. Can I move to next question?
Yes, sir.
Okay. Please read this. Which of the following are true? The lapping operation can be used for finishing external. You read this and please answer is. It is saying which are true.
Sir, D.
Which are true. It can be multiple. Only D. Malab, you are saying A, B, C are incorrect.
Sir, A
D
is
is correct.
Okay. You are saying D is correct. And please see the notes, and I have taught, I have each and every point I have discussed.
B is also correct.
Which one?
B.
B is correct.
Yes.
Okay. Okay. I don't know. Please tell me just. I'll tell later. Any more? Fine.
Sir, D and E.
D and
Lapping is also used for internal and external, no?
okay. This is final. Any more guesses? Okay, fine. Okay, then see. First is A. So lapping is, I have told lapping is used for internal versus external. So A is correct. No issue. A is to correct. A lap is generally made of material harder than work material. This is wrong. I have told lap is made up of softer materials. Right? This is wrong. The carrier fluid used in the lapping are machine oil. This is right. I have told in the carrier fluid for use in the lapping are machine oil, and this is right. And this also right because in there no mechanical contact is there. This is also right. So B is wrong. A, D and C are right. Answer is A, C and D. Fine.
Okay.
For this type of question you need to remember. You need to remember the theory. Because there is no concept in this. Just you need to remember the theory. Fine.
Yes, sir.
Okay, so next we'll go to next question. Please read this. In honing process, which are correct. In honing process, please read and answer.
Sir, A is correct.
Okay, fine. And I'm writing all three. You say which are correct, which are not correct. A is correct, you are saying, right? What about B? What about B? See, I have told you, na, कि honing and super finishing are almost same, but in super finishing some differences are there. So the lower pressure is used in super finishing, not in honing. So B is wrong. Also, it performed using loose abrasive particle. So loose abrasive particles are used in super finishing. It is also wrong. Now, it is used for tough non-ferrous, but honing is has a limitation. It is not used for non-ferrous. This is also wrong. So answer is only A. Fine.
Yes, sir.
Okay. We'll move to next question. Okay. Which of the following are correct? Please tell me. Fast, fast. These are very simple. You don't have to calculate.
B.
Huh?
B.
Wait, which is correct you're saying? A is correct or not?
No, sir.
Why?
Sir, it is actually 20, 30 something.
20 to 80. Right. Okay, B.
B is correct.
Okay, right. C. C.
No, sir. Ceramic balls, no.
Okay. For ceramic ball, what we are using? That magnetic one.
Fluid. Magnetic fluid, yeah.
And D.
Electropolishing levers. Yes, sir. It's true.
Fine. So answer is A and sorry. Answer is B and D.
Yes, sir.
Fine. Can we move to next question?
Yes, sir.
Okay. It is very simple. What is the full form of CNC and NC?
Computer numerical control and numerical control.
Okay. The answer is C. Okay. It is very simple. Next question. The G02 in command is used for?
Circular interpolation clockwise.
Clockwise.
Okay, C. And for anti-clockwise?
G03.
And for this input in mm?
Input in mm.
Hmm.
G21.
G21. Sure. G20. Okay, fine. G21. G21 only, na? 1 second. Yeah, right. And for linear interpolation?
G01.
Okay. This is G03. And feed per minute? G 20 K21 G20 sorry G98 है ना, you need to remember it. G98. Okay.
Yes.
Okay, fine. Next, match the following. Please say what is of 1, 2, 3, 4. For M01, what is M01?
Optional stop.
Optional stop. Okay. C. M16.
M9 is coolant off.
M9 is coolant off. So 3 is A. Okay. I have not given you optional. Option is also given. So see, you don't know about this, na? M19 you don't know, M16 you don't know. So in this type of question, you have to just match the option, right? So I'll just tell you, because if I would have given you option, you might have understood. So one is M01 is the change of C, optional stop. M16 is this change of heavy tools, and M4 M19 is coolant off. Sorry, M19 is this spindle orientation B. Okay, fine.
Yes.
You can
Yes,
find
sir.
this other also M code. I have also only mentioned some of the important M code, but rest you can find. Okay, please do this. 1, 2, 3, 4 for one set tell. See, some you don't know, but some you know now. So on that basis you can do.
G90 absolute value command.
Okay, 1 का C. Okay, sorry,
सर 1 का D.
सॉरी 1 का D. हाँ, G92 का C
Yes, sir.
and 3 का G28. I have told na, return to reference position.
Yes, sir. Start point.
A, then 4th का A. See, 92 you don't know, but from this you can find na.
Yes, sir.
Okay, very easy. Now, okay, tell me the path from going from P1 to P2. What will be the code? Just look at tell. It is very easy.
G02
Hmm.
X20 Y10 Z0.
G02 02 because it is clockwise, है ना? X is 20 because final position is 20. Y is 10.
R
And
is
Z is also 0. And R is how much? R is this much. R is 10.
R is 10.
This is right. But this is right in case of when it is absolute.
G9.
But
Yes,
but in when you will do G91, then X is how much? X will be 10. Okay, from here you will see from here then na. X 10. Y will be how much? Minus 10. And radius will be at. Right?
Yes, sir.
So you need to see both the option. For G91 this is right, and for G90 this is right. So if both are there, you will tick both. Fine. This is you have understood this?
Yes, sir.
Okay. What? Hello. Any doubt?
No, sir.
No, sir.
Okay. Okay. Tell me for the IJ what? G02, G90. And if you want to do the I then X20, Y10. Tell me for I. What is I and what is J here? IJ. What is I? What is I? Arey, I is what? Distance between the initial point and the
10,
center
10.
X. So I is
10.
0. I is 0 na. Because X distance, they are lying on the same line na. So there is no X distance between center and initial point.
Yes, sir.
Arey, understood na? This is center. This is initial point. So there is no X distance na. Only Y distance is there. And what is the Y distance? This 10. And it is going downwards. So it is minus 10.
Minus 10. Yes, sir.
Right?
Yes.
Okay. Always take the distance from center in the first point. Okay. See, here it is in the straight line. So X is 0. In this case, Y is 0. Fine? Okay. Last question. Please tell me the answer. First tell me for absolute. So G01 for linear, absolute G90. What is the final position?
20,
X20, Y10, Z0. So which one is this one?
First.
Also check for incremental. है ना? तो G01, G91. So what will be the X in case of incremental? This will be the X. How much it is? 10. है ना? And Y is how much? It is going from 20 to 10. It is minus 10. Z0. So do we have any this value? Yes, this value. B.
Okay, huh? Yes. B.
So answer are both A and B. So check for both. Okay, always check for both absolute and incremental.
Yes, sir.
Okay, this is done. Are you having any doubt?
No, sir.
Okay, so when you are
No, sir.
when you have to do assignment 7, when is your last day?
This Wednesday, sir.
Okay, so please complete this on time. And if you are having any doubt, then I'll upload this on YouTube. Please watch it. Okay.
Yes, sir.
Okay. Thank you. Then we'll meet next week. Okay. Bye.
Okay, sir. Thank you.
Thank you, sir.
Okay.